Hey everybody, this is our polar unit video 4, and we're going to be evaluating some polar equations using our calculator. So please have your graphing calculator available. If you don't have a graphing calculator, then make sure you take really good notes so you can try this. But your calculator is going to be a big help for you, so you're going to need some sort of calculator with you. All right, let's get started. Okay, so a few things to set up your calculator. Well, first thing you need to do is you need to make sure that your mode is set correctly. You need to be on degrees. And then I believe it's the fourth one down, and it says function, PAR, POL, and SEQ, and you need to make sure it's highlighted on polar. Then you need to go to second window. And when you're in second window, you need to take a look at, second window. The first thing it should say is table start, and table start should be at 0. And the second one, it says delta table, and delta means change, and you want that to be on a 15. Okay, the other two should say auto, and you should be ready to go. All right, now go to your y equals, and when you go there, you should notice that it actually says r equals. So that's because when we do these polar graphs, we're actually doing r comma theta. That's what the polar values are. So your r comma theta. All right, so type in 1 plus the cosine of theta. You're like, where do I get cosine? Well, you get cosine by hitting x. When you're in polar mode, it knows not to use x. It knows to use theta as the input value. Okay, so if you go ahead and type that in and then go to table, so you're at second graph, you'll notice it starts counting by 15s. I don't really want all the 15s. I only want certain values. I want the ones we've been using for our unit circle. You'll also notice that my table is set up backwards compared to the calculator. So change this to theta, change that one to r, and we'll do it the way the calculator has it so there's no confusion. So I want 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, and of course we can continue into the fourth quadrant. If you're wondering where I got those values, look very carefully at where I got those values. Okay, now I'm just going to write down my r values. So there's not a lot of thinking involved in this. It is merely copy them out of your calculator. If you don't have a graphing calculator, but you have a scientific calculator, or even your cell phone available for at home only, then you may actually type in 1 plus the cosine of 0, 1 plus the cosine of 30, 1 plus the cosine of 45, and you'll get the same values. The table does it all in one whoosh for you. So, going to copy these down rather quickly. If you can do this without my help, then go ahead and just do it and don't worry about me. Notice I am skipping the values that I'm uninterested in, like I didn't need 15 degrees and I didn't need 75 degrees. So let's see, 90 degrees was 1 and 120 is 0.5. All right, so I've completed my table. And to be honest, this is as much as I want you to be able to do with the graphing calculator without me. So if you can go ahead and just complete the table, then you've got everything we needed. All right, let's take a look at this one. So for anything with an r squared value, we have to do one thing before we're even able to enter it into the calculator. And that is we have to take the square root of both sides because we can only enter in r equals, not r squared. So I will have to take the square root of the sine of 2 theta. Once again, if you have a non-graphing calculator or you're using something else, you must also do this and be careful as you're entering it because you might be doing sine of 2 theta and then take the square root of it. So graphing calculators are always helpful. Well, we will find that I can actually go from 0 to 180 because I'm going to get the positive and the negative r value. And any r value that is a positive 2 and negative 2 puts me into the third quadrant. So this will just basically carry me back across the pole so I actually get the reflection. So for this one, again, these are going to be backwards. So we're going to have theta here and r over there. We're going to write plus or minus, and I only have to go from 0 to 180 degrees. 35, 150, 180, and I can stop there because you will see them repeat. If that's a little confusing to you, I will definitely explain it in person. Okay, so back to your graphing calculator. In r equals, we are entering in the square root of the sine of 2 theta. And on your table, let's go ahead and take a look at those values. So I get 0. For 30 degrees, we get 0.9306. For 45 degrees, it's 1. For 60, 0.9306. For 90 degrees, it's 0. You'll notice these are going to, these are all errors. Actually, for 180, we've got a 0. But the rest of those are errors, which means that there are actually no values that fall greater than 90 and less than 180. So there's nothing that actually falls in the second quadrant. Well, we also, because I'm using plus and minus on my radius, nothing will also fall in the fourth quadrant. The values for these will only be in the first and third quadrant. Okay, for r equals the cosine of 2 theta, go back and change your r equals and change that to the cosine of 2 theta. And let's look at that one on our graph, or on our table. So once again, we're going to switch these columns because I typed the table wrong, theta and r. And I have 0, 30, 45, 60, 90, 120, 135, 150, 180, 210. This one I'm going to have to go all the way around the circle for. 225 and 240, and of course this would continue on my chart, my table, but we'll just look at those. And the radius is 1, 0.5, 0, negative 0.5, negative 1. Not very exciting. 120 is negative 0.5. Then I have, for 135 is 0, then 0.5, 180 degrees is 1, and it looks like these things are going to start repeating. 0.5, 0, negative 0.5. Okay, so not very exciting in this, but you'll see that this isn't even very large. If we were to go ahead and insert a number here in front of that, then all of these would be multiplied by whatever number we had. So you'd see that that would definitely change the size of this graph and the outcome. All right. So if you can type those into your y equals or your r equals screen and pick out only these values, then you've got exactly what we needed. Next up, we're going to be looking at the difference between different polar equations. When you finish this part of the video, you should be able to identify, maybe using your notes, but eventually without using your notes, and name the different equations and what they look like. The first type we have are called circles. Our circles come in 3 different forms. R equals 4 is a circle with a radius 4 that is centered like this. That means in all directions the radius is 4. No matter where we are on the circle, it has a radius of 4. 2 cosine of theta is going to just be turned a little bit, and it's actually going to be a circle that looks like this. 3 sine of theta is going to be sitting on top of the x-axis like that, but those are all considered circles. The next one, pronounced lemniscates, will make a figure 8. So if you can remember lemniscate, figure 8, they are one and the same. We're going to call them by their proper name, lemniscates. These are the ones we had when we had the r squared involved, where we would have to take the positive and negative. And because we're doing that, we're actually going to be eliminating two of the of our quadrants, perhaps, or different areas. So my cosine graph for this is going to look like this type of figure eight. And this 4 determines the size of that, how big it's going to be. So how far these are traveling out to their max. The 9 here will do the same, except this one is going to be on a diagonal. So it's actually going to look like this. All right, next up. A limacon, and it's French. I'm not going to pronounce it correctly, has a plus or minus b sine of theta or a plus or minus b cosine of theta. To determine the different shapes that this is going to have, you have to take a ratio of the a and the b. If the ratio of the a and the b is less than 1, then you kind of get this loop inside of a loop. It looks like this. If a and b are exactly the same, then it kind of makes what some might call a heart. And the heart kind of looks like this. Now it doesn't come to a point, but it actually comes and meets back here at 0. So you get this kind of heart shape. And if the a and b falls between, that means this little heart part, the part that comes back in, it doesn't go in as far. It looks kind of more like a lima bean. And it'll come in like this. So it doesn't come all the way back to the origin. And this one I like to call a flat tire, because you'll see that it'll actually be like flat on one side. So it's not a circle, it actually is flat, and that's if the ratio is greater than 2. Okay, and the last one, the most exciting one, is a rose curve. And a rose curve, it doesn't have any pluses and minuses, but the number that's in front of the theta tells you how many petals there's going to be on a rose, on a flower. So if you were to substitute in here any number that's even, let's say 4, you would double that 4, and that's how many petals there would be. If this number is odd, like 5, then it's exactly that same number of petals. So odd stays the same and even is doubled. So these will look something like this. So this one would have 8 petals that I'm going to draw. So 8 petals. And an odd one, I'm going to draw one with 3 petals, would look like this. And they all are centered at the pole. Those are called rose curves. Okay, so let's identify which ones these are. We said anything with a plus or minus. Anything with a plus or minus is going to be a limacon. So I have a ratio of 3/1, so this is a limacon. And the ratio is 3/1, which means it's greater than 2, so it's kind of going to look like a flat tire. The next one is going to be, it's got a 4 in front, I've got that, so this is a rose with even numbers, so I double it, 4 petals. Oh, the squared. Anything that's squared is going to be a figure 8, so that's our lemniscate. And I've got 5 times a number with nothing multiplying it. So when there's nothing multiplying it, that tells me that this is a circle. So the difference between example 5 and 7 is that there's a multiplier on the theta. That gives me the rose. If there's nothing in front of theta, it's a circle. Okay, so your homework is to write these down or use your note sheet here, and I want you to type them in. Make sure you take the square root on r squared, for example number 9, so that you can appropriately get the right answers. We're going to check these over after you complete the tables. That's what we'll start with tomorrow in class. All right, so the 2 things that you should be able to do by the time you finish watching this video before you get to class tomorrow is you should be able to complete a table of values. either using the graphing calculator table of values or your home screen where you're just typing in 3 times the cosine of 30, 3 times the cosine of 45. So you must be able to make a table of values. You also want to know the names and the features of the 4 types of graphs. Okay, if there's any questions, you can go ahead and leave me a note on Schoology or communicate to me via email.